Uh, hello, my friend. This is Dr. Sirme, and for the month of March and April, students will be at home. So what I'm going to do is to engage them. I will engage them through this platform that is the Dr. Sirme GK YouTube channel. And like for instance, in this one, we're going to revise a full paper. That's a Form 1 chemistry paper. So it's upon you. Provide your student with the necessary equipment, be it a smartphone, be it your laptop. This is the high time you allow them to access to these gadgets because it will be very instrumental, very useful. Maybe you only need to regulate that your student will not go to other sites, but we are basically doing chemistry and mathematics. So what I'm going to post is a paper. I'll first of all post the questions, then I will post the answers.
Okay, first I'm just uploading the questions without the answers. Then towards the end, I will include the answers. So what you can do is to attempt the questions, then you go ahead and now go through the marking scheme, and of course you can mark for yourself. Okay, with question 1, you're supposed to answer this a question on apparatus. You're supposed to name the apparatus that can be used to support crucibles when you're heating. The part Roman 2, you're supposed to name an apparatus that can be used to hold hot solids or corrosive one. Question 2, you have a table. This is a table of pH values of solution A, B, C, D, and E, of course, and F. Then you select the solution or the substance that has a pH corresponding to a weak acid, then a strong base, then a strong acid, then a weak base. Good. Part B of it, you name the substance that was used to determine the pH values given on the table. Question 3, you're given a table of elements. These are elements and their symbols. However, the symbols are not, some of them are not the correct one. So you're supposed to either put a tick or a cross, depending. If it is correct, you put a tick. If it's wrong, you put a cross. Then question 4, you differentiate between a mixture and a compound. Question number 5, you're given two flames, X and Y. So Roman 1, you're supposed to identify the two flames, X and Y. Then you state the condition under which Y is produced. That is Roman 2, Roman 3. You name the part of the flame X labeled A, B, C. Then you go to question Roman 4. You are supposed to identify the flame that is used for heating, that student can use for heating. Then part B of it, give 2 reasons for that. Okay, going on. Question 6, you're given a setup. It's a method of separating mixtures. Good. You're also given apparatus B, C, apparatus E, solid F, then liquid G. Then name the method of separating mixture that is given. Roman 2, what properties of F and G that makes it possible for you to separate them using the above method. Then Roman 3, you're supposed to give the name of solid F and liquid G. And then Roman 4, you go ahead and identify the apparatus B, C, and E. Going to number 7, another setup for preparation of oxygen. You have apparatus Y, then a round bottom flask containing sodium peroxide, a liquid X from an apparatus there, then the gas is collected over a liquid there, that is over water, and of course some other apparatus not identified. So Roman 1, you identify the substance marked X, the apparatus Y, and then the apparatus Z. Roman 2, you write a word equation. Remember, this is Form 1 work. Basically, a word equation for the reaction inside the round-bottomed flask. Then you go ahead and you name the method of gas collection that is used in the setup. Roman 4, you state the properties of oxygen that makes it possible for the student to collect oxygen in the above or using the above method. Well, then what is the confirmatory test of oxygen? And go ahead and give two uses of oxygen gas. Question 8, your toad candle is a hydrocarbon. So the question is, what is a hydrocarbon? And then give two substances that will be formed if you burn candle wax. Then question 9, you're given a setup that is used to investigate the percentage oxygen in the air. You're starting with 90 cubic centimeters of oxygen or air in cylinder A. Remember, cylinder B is closed, is empty. Then after the experiment, 72 cubic centimeters of air remained in cylinder A. And of course, cylinder B just remained empty. Inside the combustion tube are the copper turnings that are being heated. And of course, the air is passed over it repeatedly and slowly. Good questions. You calculate the percentage oxygen or the percentage air that was used up during the experiment. Roman 2, you're supposed to explain why air was passed over heated copper turning slowly, and part B, repeatedly. Then you go ahead to Roman 3. You state the purpose of glass wool. You can see on the setup the glass wool. They are fixed to the end of the combustion tube. Then Roman 5, you give the name and the color of the final product in the combustion tube. And then Roman 5, you write a wordy question for the reaction taking place inside the combustion tube. That is question 9. Question 10, you're given that sulfuric 6 acid was reacted with a compound P of magnesium. Then there was a colorless solution Q and a colorless gas R. Then that colorless gas R formed white precipitate with lime water. Then you name compound P, solution Q, colorless gas R, and finally you write a wordy question for the reaction, I think is between sulfuric 6 acid and compound. Okay, question 11, you name a compound that consists of oxygen, nitrogen, and sodium when they are chemically combined. Question 12, Roman 1, what is the chemical name for rust? Then state two conditions that can speed up the rusting process. Roman 3, you're given a setup, or you're given a setup of 3 boiling tubes there. The first one, there is anhydrous calcium chloride fixed there over cotton wool. Some nails are in there. Then you have the setup B, the oil placed over boiled water, some nails inside. Then setup C, there is the tap water and of course the nails. You explain the observation that will be made in each of the test tube or the boiling tubes A, B, C after 48 hours. Okay, next is question number 13. Question number 13, you give 4 differences between what we call the permanent or the chemical change and temporary, what we call physical change. Question number 14, you're supposed to name the method of separating mixtures. One that can be used to obtain salt and water from a salt solution. Then obtaining oil from castor seeds. Then obtaining colored matter from green leaves of a plant. Question number 15, you define the 3 terms: melting, condensation, and sublimation. Question 16, you're given a setup, and the setup, there is a solid being heated, anhydrous copper 2 sulfate. Then of course a colorless liquid L is collected somewhere over cold water. Then in Roman 1, you're supposed to state the color of the product formed in the ignition tube. Then name the product formed when hydrated copper 2 sulfate crystals are heated. One observation that's Roman 3, that will be expected in the ignition tube when the substance cools, and of course few drops of water are added. Then we go to Roman 4, how you can determine whether liquid L is pure or not. With Roman 5, you give a wordy question for the reversible reaction taking place when hydrated copper 2 sulfates are heated. Then question number 17, name the products that will be formed if dilute acids are reacted with metals. all the part B, they are reacted with bases. You then give the word equation. This is form 1, so no chemical equation, a basic word equation. Zinc metal reacting with hydrochloric acid. You write a word equation. Sodium hydroxide and sulfuric 6 acid. You write a word equation. When you burn hydrogen in air, what will be the word equation? Question number 18, you state and of course define the term fractional distillation. Then during fractional distillation of liquefied air, you state how you can remove the dust particles, then how you can remove water vapor, and how you can remove the carbon dioxide gas. Question number 16, no, that's 16, but this question number 19, you define the term diatomic molecule. And of course, Roman 2, give one example of a diatomic molecule. Question number 20, 3 uses of hydrogen gas. Question number 21, Roman 1, you state the commonly abused drugs. With question 21, Roman 2, 2 effects of hard drugs, that is drug abuse. And that is the end of the paper. Kindly attempt the paper before maybe you start going through. And now we go through the marking scheme. Question 1, the apparatus you use to support crucible. It is the pipe clay triangle, not the tripod stand. The pipe clay triangle, just the one I've tried to draw for you there. So it's not the tripod stand. The apparatus used to hold hot and all corrosive solids, that is a pair of tongs, as I have indicated there. Then on the table, the pH corresponding to a weak acid is A, that is 6. Then that's a weak acid. Roman 2, a strong base. A strong base is 13, that is substance B. Remember from 11, pH value 11 and above, those are strong bases. Then strong acids, that is the pH values less than 3, and it is C. With the weak base, that is a pH value slightly above 7 and less than 10, 11 there, it is substance D. The substance you can use to determine this pH is universal indicator solution. It goes together with a pH chart. It can help you now get the pH values. If you look at the table, that's number 3, iron, the chemical symbol given there is correct. So that's a tick. Nitrogen, the chemical symbol given is wrong. That's for nickel. Nitrogen is capital N without the I. So that's a cross. Potassium, that's kalium, capital K, correct. That's a tick. Sodium, the symbol is wrong because sodium is N capital and a lowercase a. That's natrium. So copper, the symbol given is correct. Oxygen, the symbol given is wrong. Oxygen is capital O without the X. The difference between a compound and a mixture, that's question 4. A compound, you only state that the elements are chemically combined, and it's of course a pure substance. Chemically, the elements chemically combined. But a mixture, the components are physically combined and not necessarily chemically combined. We go to question 5. Flame X is the non-luminous flame. Look at it, it has 3 regions and it is short and steady. The other one is of course luminous. Luminous is the Y. The condition under which Y is produced, the air hole must be fully closed. I think that the correction is done there. For Y to be produced, the air hole must fully be closed. Then Roman 3, the region A, the outermost of a non-luminous flame, it's a pale blue region. The center one is the green-blue zone. Then C is a colorless, the almost colorless zone. Other is called the unburnt gases. Okay, with the Roman 4, the flame that you can use for heating is flame X. Otherwise, having identified it in Roman 1, you can state the non-luminous flame. Then give 2 reasons for this. The non-luminous flame is hotter. Remember, the gas is burnt completely, so the amount of heat produced is higher, and does not produce soot, of course, because the gas is burnt completely. Number 6, the method of separating mixture. This is filtration. The properties of G and F. G is insoluble, while that's F is insoluble, while G is soluble. That makes it the method possible. Roman 3, F is the residue, G is the filtrate. Then Roman 4, apparatus marked B is the conical flask, C is the filter funnel, the filter paper, actually it's the filter paper, while E is question number 7, the substance X that is being reacted with sodium peroxide, that is water. If the sodium peroxide was replaced with manganese oxide, then X will be hydrogen peroxide. But for this, X is water. Going to Y, it's a dropping funnel. Z is a beehive shelf that is supporting the gas jar. The word in question, sodium peroxide reacting with water to get sodium hydroxide solution and oxygen gas. This method is called over water method. Roman 4, the method is good for collecting oxygen because oxygen is slightly soluble in water. Give a confirmatory test of oxygen. Oxygen will relight a glowing splint. Uses of oxygen, as many as they are in book 1, used to make oxyacetylene flame for welding and cutting metals, used by deep sea divers and mountain climbers, all that to support, support life. Then can be used to remove impurities when you're extracting steel or steel refinery. It can also help to burn fuel that propel a rocket. And question 8, hydrocarbon is a compound of carbon and hydrogen only. Example, wax, polythene, other compounds called alkanes, alkenes, alkynes, among others. 2 substances that are formed when you burn a hydrocarbon. There is water and carbon dioxide. Then question number 9. The setup you have there was to investigate the percentage active part of the air. Basically, that is oxygen. Question 1, or the Roman 1, you're calculating the percentage by volume. That is the air used during the experiment. If you consider the syringe A, the initial volume of air was 90. At the end of the experiment, the volume reduced 72. So the volume of air that was used up was 18. So to calculate the percentage, it will be 18 divided by the initial volume, that is 90, then multiply by 100, and you get 20%. The question will always be, why not 20.9, the theoretical value? Obviously, there are some experimental errors that you need to know. Roman 2, why was the air past overheated copper slowly? That is to allow more time for the contact between now the reactant, that is the copper metal and the oxygen or the air. Why was it passed repeatedly? Repeatedly was to ensure all oxygen inside the container or the apparatus was used up. So to ensure all oxygen was used up. The purpose of glass wool is to prevent copper turning from being sucked or being blown into the syringe or the 2 syringes. Okay, the next question, the substance being formed inside the combustion tube is copper oxide, and copper oxide is black in color. The word equation, copper metal reacting with oxygen to form copper oxide. Question number 10, you're given that sulfuric 6 acid is reacting with a certain compound of magnesium, a colorless solution Q, and of course a colorless gas R that forms white precipitate with lime water. So with that, gas R gives us the first hint that most likely the compound P is a carbonate. So it's a carbonate of magnesium, and that is compound P, therefore it's magnesium carbonate. If you talk of solution Q, it is magnesium sulfate solution. Gas R is carbon dioxide gas. The equation, magnesium carbonate reacting with sulfuric acid, you get now the magnesium sulfate solution, carbon dioxide gas, and water. Remember, that is typically what happens when a carbonate reacts with an acid. 3 products: a salt, a carbon dioxide, and water. Question number 11. The compound made of sodium, nitrogen, and oxygen. Most likely, it is sodium nitrate. Remember, a compound ending with ATE has oxygen in it, and of course nitrogen. Remember, it can also be sodium nitrite. Sodium nitrite. It is also made up of sodium, nitrogen, and oxygen. We go to the next question, number 12. Rust is basically hydrated iron 3 oxide. Remember, it is iron that react with oxygen in presence of moisture. Conditions that speed up rusting: the acidity, saltiness, or what we call salinity, and high temperature. If you go on with the rusting question, the three setups as you can see them. We go direct and state what is happening in setup A. There will be no rusting. The reason being, the anhydrous calcium chloride is deliquescent. It has a good ability to absorb moisture. So inside A, test tube A, there is no moisture. So one condition for rusting is absent, and therefore it will not rust. That's the explanation. B, the boiled water has no oxygen. So the observation in this case, there will be no rusting. The reason being, absence of oxygen, because by boiling the water you expel oxygen. And look at the oil. The oil will prevent a re-entry of oxygen into the water. We go ahead to part C. C, rusting will occur. Tap water do contain oxygen, dissolved oxygen, and therefore with the two conditions necessary for rusting, therefore the iron nails will rust. But part B of the same method of preventing rusting, any two: oiling and greasing, painting, galvanization, electroplating, alloying, sacrificial protection, any two will earn you the 2 marks. Question number 13, differences between chemical or other what we call permanent change and temporary change, others called physical change. We start with we will, as the table shows, we have the permanent. We shall start with the permanent change, then we have the temporary. With the permanent change, there is change in mass, but with the physical change, the mass remains the same. The substance just assumes different state, but the mass remains the same. With the permanent change, it is accompanied by change in heat. There is heat change. But with the physical change, no heat change. It's a physical combination. With permanent change, new substances are formed. With physical change, no new substance is formed. With the permanent, it is irreversible. The other one is easily reversible. Basically, think of, for example, when you burn copper metal, you get copper 2 oxide. That's a permanent change. The properties as we have listed, those characteristics will apply. But for example, if you dissolve salt in water, that's a physical change. You can easily reverse it. No new substance are formed. Okay, with question number 14, the best method you can use to obtain salt and water, you recover both from a mixture, it is simple distillation. Remember, evaporation will not work, because once you evaporate, you're going to get the residue, yes, that is the salt, but water will escape. But with simple distillation, you are able to cool the steam and then you obtain the solvent. Obtaining oil from castor seeds, that is solvent extraction. You are getting a suitable solvent like propanol, then you do solvent extraction. Separating different components of colored matter in green leaves, that is chromatography. Remember, for number 14, each question is 1 mark, not a half. Go to number 15. Melting is a physical change of state from solid to liquid when you heat a solid, that is. Condensation, a physical change of state again, from a gas to liquid when you cool. I think that correction is there. So when it is cooled. Direct change of state from solid to gas, that is sublimation. Number 16, with number 16, the setup is there. You're heating hydrated copper 2 sulfate. If you heat it, it will change from blue, and finally, Roman A, the color will be white. Okay, going ahead to Roman 2, you're supposed to name the final substance that will be in the ignition tube. that will be anhydrous copper 2 sulfate. Now the white substance, and of course water will also be produced. It is the colorless liquid L on the other side. Good. You state the observation that will be expected in the ignition tube again. When you cool, then you add few drops of water. Remember, you're doing a reverse of the heating process. Then the color of the substance that is now white will go back to blue. It's a temporary chemical change. So how will you determine the purity of L? Remember, L is water. So you heat this liquid to boiling, and at sea level, it's supposed to boil at a constant temperature of 100 degrees Celsius. Okay, the reversible equation for this, it's hydrated copper 2 sulfate. You heat the forward one, you get anhydrous copper 2 sulfate and water. You cool with introduction of a few drops of water, then it goes back to the hydrated form. The next question is number 17. Good. If you react acid with metals, you're going to get salt and hydrogen gas. If you react acid with bases, you're going to get salt and water. That's a neutralization reaction. Roman 2 of the same question, you're writing word equation. The word equations are as I've written down there. Zinc reacting with hydrochloric acid, you get a salt, zinc chloride, and hydrogen gas. Sodium hydroxide and sulfuric acid, a base and an acid. You get sodium sulfate and water, a neutralization reaction. If you burn hydrogen in air, it forms water. It burns with a blue flame to form water. Question number 18. Fractional distillation, a method of separating miscible liquids with close but different boiling points. We usually say the range should be less than 40 degrees Celsius between the miscible liquids you're separating. We go to Roman 2. We state how you can remove the following substances as you do fractional distillation of liquefied air. The dust particles, you pass them through dust filters, or we call the system of filters. The process is called dust precipitation. So you do dust precipitation. How do you remove water vapor from the air? You cool the air to negative 25 degrees Celsius. Water will come out in form of ice. Good. Carbon dioxide, you get an appropriate chemical that will absorb carbon dioxide. And the best chemical we use is the concentrated sodium hydroxide solution, or the sister chemical, potassium hydroxide solution. They have very good ability to absorb carbon dioxide. A diatomic molecule, it's a molecule made of two atoms of the same kind chemically combined. Examples: oxygen exists as a diatomic molecule, nitrogen, hydrogen, chlorine, bromine, among others. Question number 20. 3 uses of hydrogen, as they are listed in book 1 again. Manufacture of ammonia in a process we call Haber process, in welding and cutting of metals. So hydrogen can also be used to make the flame, the welding flame. Can be used in hardening of oil, that is hydrogenation. Process that can lead to formation of margarine. Then can also be used in rocket fuel, among other uses. 2 commonly abused hard drugs. We have the alcohol, the bang, the mira, or what you call the cat, cocaine, among others. 2 effects of drug abuse. Remember, these are quite a number. The drug abuse effect can range from health, socio-economical, or any other approach. If it is social, basically hard drugs can cause stress, depression, hallucination, truancy among youths, withdrawal syndrome, divorce among the couples, fighting, and many other. When it comes to health, liver cirrhosis like alcohol can cause that, lung cancer for tobacco. You remember now, tobacco is still another hard drug that is oftenly abused. Blindness, some people have consumed illicit blues, and it has been reported they have lost sight. Mental problem, among many other. Others, that was a Form 1 full paper covering all the topics from introduction to chemistry all the way to water and hydrogen. kindly keep coming for more, because we're going to post more full papers, both chemistry and mathematics, for the sake of the lovers of math.
And this is Dr. Sirme. And what I want to do is to welcome you people for our virtual classes, online classes. Do not let your students waste all the holiday staying at home. 2 hours will be enough. 2 hours will be enough with Dr. Sirme. Join other students. We are having a number of students. And as they interact, they're going to share experiences. They're going to maybe have experiences from different schools, and I know they will learn. It will not just be academic learning, but it will also be social learning. Learning what do students do in other schools different from maybe what your kid do. Otherwise, thank you so much. This is Dr. Sirme. So book your lesson, book for your student, and I'm sure your student will benefit a lot. Otherwise, thank you so much. Do not forget to join us into our virtual lessons. Thank you so much, and thank you so much.